So time series data, well, the name gives you an indication of what's going on. So the first thing that we know is that it's data collected at regular time intervals. So it can't be data that's collected this week on Monday, next week on Friday, they're not for another 3 weeks. That's not regular time intervals. What I mean by that is data that's collected every Monday of every week, or at the end of each month there is a total made, or at the end of each day. So it's data that is collected over time. So for examples, all the shops that we go to, at the end of each day, they total the amount of sales that they have made. Another example, businesses have to report to their shareholders, so they're the people that have invested in the company, and they have to do that every quarter year. So if I take a year, which is 12 months, divide that into 4, 12 divided by 4 is 3, so every block of 3 months is 1 quarter of the year. So January, February, March would be the first quarter, April, May, June, second quarter, July, August, September, third quarter, October, November, December, fourth quarter. So a 3-month period of time would be quarterly data. So let's have a look at an example. So let's take some umbrellas, okay? What we want to know is that how many umbrellas have they sold every season? And we want to first of all just understand what the graph might look like. So we're going to predict this. So I've got the axes set up. I've got on the bottom axis, on my horizontal axis, I've got the time. In this case it's the season, spring, summer, autumn, winter. And on my vertical axis is my sales, and that's the sales of my umbrellas. So let's start by thinking, what might the sales of umbrellas be like in spring? Well, I think that's going to be somewhere around mid-range. Okay, so in spring we're still getting showers, we're coming out of winter, so we're still getting some rain, people are still buying umbrellas, but it's not really high like in the middle of winter when we get a lot of rain. In summer, people still buy umbrellas in summer, for sunshade and things like that, but not anywhere near as much as at other times of the year. So I'm predicting that summer it's quite low. In autumn, I expect it to be higher than summer. We're starting to get some more colder weather, we're starting to get some showers coming in, but not a huge amount yet. But in winter I expect the sales to be very high. So you can see there I've plotted 4 points, spring, summer, autumn, winter, and I've got the sales of umbrellas. To make this into a time series graph, I'm going to connect these together with lines. So this is a line graph, and that's what a time series graph is. So now I want us to think about this idea. That pattern, the one that I've just drawn here, really high in winter, lower in spring, lowest in summer. So that pattern, do you think that pattern is going to repeat every year? So do you think winter this year will have higher sales, just like winter last year did, and the winter the year before did, and the winter the year before did? And I think I'm confident to be able to say that because people buy umbrellas due to the weather, unless the seasons change, I think there'll be the same pattern occurring every year. Then I want us to think, well, why might it be good to have several years of data? If I've just got 1 year of data, like I do here, I've just got 1 year of data, I can see that pattern over a single year. But I might be interested in over longer term. So do I look at buying a umbrella business? Are the sales of umbrellas increasing over the last 10 years? Have they been decreasing over the last 10 years? Are they pretty stable? So I want to be able to look at this pattern over several years of data, because that gives me, so within a year I have a certain type of pattern, and that's called seasonality. Then from 1 year to the next year to the next year, so over a long period of time, several years of data, we have that overall trend that we're talking about. So there's 2 key ideas that we're starting to think about here, trend and seasonality. So here's a look at some sales of umbrellas over a period of time. Okay, so I've got data going from 2000 all the way up to 2012, and I can see that the amount of umbrellas that have been sold each year goes up and down, depending on what time of the year it is. But overall, I would say overall it's reasonably stable over time. And we'll go into that in more detail shortly. Now let's take about toy sales. So if I think about toy sales now, and I'm going to do this by month now, so Jan, Feb, March, etc. I'm going to start with when I think the sales of toys are going to be the highest, which is in December. So I'm putting a really high dot up at December. I also know that in November, some people start buying presents before Christmas. So some of them just do it just in December, just before Christmas. But some people start in October and November, start buying things to put aside. So I'm going to say that October and November, the sales are starting to go upwards. I'm also going to think about January. If we think about for Christmas, lots of people give money as a gift. And so people then go out and wait for the sales. So then they'll go into their January sales and go and spend that Christmas money they've got. So I think the sales in January is not going to be as high as December, but maybe somewhere between October and November, somewhere around about that level of sales. This is me predicting. Whether or not this is true, I'll have to actually get some real data to prove it. But I'm starting off by thinking about the story behind the graph and then thinking about what the pattern might be. You'll be doing it from the other point of view. You'll see a graph with a pattern and you'll have to try and tell the story. So what about then the other months of the year? Well, I know that every month of the year children have birthdays. So I think that every month of the year there's going to be around about a similar amount of toys being sold each month, just from birthdays. So there's my prediction, and I'm going to join all of those together, and there is my predicted toy sale graph just over 1 year's time. So if I now think about, well, what about how does that change over time? Well, one thing that might affect it might be the number of female babies or male babies born in New Zealand. And I can see that in some years there are more babies born, and some years there are less babies born. So that might also be reflected, that pattern. If there's more babies being born in some years, maybe we'll have more toy sales in some years. And if there's less babies born in some other years, maybe there'll be less toy sales in those years. So there's a whole variety so there's a trend and the seasonal pattern that we want to be able to think about. So just to pull this all together, let's think about time itself. We can have time series graphs that fit into any number of different patterns. So we could have data collected every second, every minute, every hour. And often production lines and factories will often have data collected every second or minute or hour. We can have data collected every week, every day, every month, every quarter. And that's what we talked about at the beginning. So quarterly data would be every 3 months, not every 4 months. And that's 4 times a year. We can talk about biannual data. So that's every 6 months, there's 2 data values a year. Or annual data, which is once a year. Like our tax department often want to know the year end. So they want to know over the last entire year, how much money have you made? So there's a variety of time that we could have along that axis. Why are we connecting those points together rather than having them as separate? And this is quite important. It's because there is a relationship between those points. Our data is all about that same variable. It's all about umbrella sales, and the data is connected together over time. So because there's a connection or a relationship between the points, the graph must show that. Some people will draw time series graphs as bar charts rather than as line graphs. So you may come across that, but it's going to be very unlikely. The people who write the exam know to draw line graphs for time series graphs. So that's the kind of graph you're likely to see.